Disparate media applications are rapidly collapsing into a single, unified workspace, replacing the fragmented post-production pipelines of the previous decade. The core friction in modern post-production stems from the extreme fragmentation of deliverable formats required by clients today. A single project now routinely demands HDR motion picture assets, Lottie web graphics, immersive VR 180, and raw stills. DaVinci Resolve versions 20 and 21 finalize the platform's transition from a specialized color finishing suite into a complete media ecosystem. This architecture relies on a semantic to nodal concept, managing media at a highly automated level while executing finishing tasks at a deep structural level. To understand this system, we will trace the architectural journey of a project, moving directly from ingest to delivery through the software-specific pages. Eliminating translation loss and round-trip exporting alters the basic economics of post-production labor, reclaiming countless hours previously lost to rendering and file transfers. The pipeline begins in the media pool, where the initial ingestion logic has been entirely restructured. The introduction of AI and telesearch shifts media discovery away from manual logging by assistant editors. This diagram illustrates how the system semantically scans raw footage, instantly filtering thousands of clips to locate specific faces, objects, and spoken dialogue. These search parameters immediately populate the results as fully editable clips, ready for the timeline. Version 21 introduces a dedicated photo page, integrating still images directly into the video pipeline. The workflow supports direct camera tethering, while Lightbox views provide a macro-level overview of entire albums. The image processing pipeline allows for reframing and cropping to occur non-destructively at the original source resolution, handling assets up to 32K. This marks a departure from traditional layer-based photo editing, allowing photographers to utilize node-based raw grading. Applying Hollywood motion picture color science and nodal logic to still photography removes the barrier between video editors and photographers, uniting them in a single workspace. With media organized, the pipeline moves into the cut and edit pages. Structural keyframing updates include 4-point Bezier retiming and new ease animation modes, bringing high-end cinema retiming controls directly into the standard editorial timeline. The cut page utilizes smart bins to execute automated timeline organization based on dynamic metadata rules. The studio version introduced Multicam Smart Switch, a tool designed to bypass manual multi-camera workflows. This interface shows the Multicam Smart Switch. Instead of relying on audio syncing, the neural engine executes a multicam rough cut. The AI tracks specific visual traits, identifying lip movement and distinguishing wide shots from close-ups to find the optimal speaker. Text-based workflows expand with IntelliScript, providing native import and support for plain text screenplays. The AI speech generator allows editors to transform written text into spoken voice, enabling rapid voiceover prototyping without leaving the timeline. This algorithmic approach to editorial shifts the editor's burden from brute force manual synchronization to high-level parameter direction and creative refinement. The pipeline next enters the Fusion page for deep spatial manipulation and compositing. Fusion integrates the Crocodile VFX library directly into the software, alongside native drag-and-drop support for Orgraph and Lottie animations. Here we see the improved macro editor. This redesign solves bottlenecks for motion designers building complex node chains. A live preview panel delivers real-time feedback, clarifying how parameter checkboxes will appear while the macro is being built. Deep architectural 3D updates include support for USD SDK 25.11 and the Hydra 2.0 API, upgrading the built-in Storm renderer. For audio finishing, the Fairlight page introduces track folder management, allowing editors to group, expand, and collapse complex track hierarchies. A highly specific crossover tool is the new Fairlight Animator modifier. This diagram visualizes how the animator modifier reads audio levels to directly drive Fusion animation parameters in real time. This builds on the audio processing tools introduced in version 20, including IntelliTrack AI, EQ Matcher, and Dialogue Matcher. The direct cross-pollination of audio data and spatial nodes eliminates the historical wall separating motion graphic departments from sound mixing suites. The final stage of the pipeline occurs in the color and delivery pages. Structural updates include color slice 6 vector grading and the ability to view complex node graphs as a streamlined layer list. Group color grade versions allow colorists to create and manage multiple grade iterations, maintaining strict visual uniformity across episodic projects. The delivery workflow is streamlined by the multi-master trim pass. This visualization demonstrates how colorists can generate color-managed HDR and SDR deliverables simultaneously from a single timeline. Delivery is backed by Neural Engine, featuring CineFocus and Face Age Transformer, AI blemish removal, and ultrasharpen. AI Motion Deblur actively reconstructs damaged pixel data, rescuing artifact-heavy slow-motion footage by stripping away unwanted camera blurring. Immersive delivery parameters now include foveated rendering for Apple immersive workflows, which selectively prioritizes GPU load directly to the center of the viewer's gaze. Nodal output architecture and targeted foveated rendering allow studios to meet deeply fragmented delivery requirements without crushing their existing hardware infrastructure. The architectural map of DaVinci Resolve versions 20 and 21 reveals a fully contiguous post-production environment. Versions 20 and 21 reconfigure the post-production sequence by housing every finishing department within a single shared database. It seamlessly integrates raw still processing, AI-driven semantic editorial, deep USD compositing, and multi-master delivery. Because this entire process occurs within a single unified environment, the traditional concept of workflow translation loss is completely eliminated. A unified nodal architecture addresses the translation loss inherent in segmented stacks, establishing a higher efficiency ceiling for high-output media environments.